We finally get to overclock our non-K Alder Lake processor. But in order for me to explain how to do it, I have to explain a little bit on how Intel enables overclocking on their K CPUs. Let's pick up the story where we left it at Nehalem. The integrated power control unit was a key innovation of the Nehalem processor as it provided Intel control over the CPU's power management. Via its integrated microcontroller, Intel could set the power and performance rules of its processor, govern it, and if necessary, even change its behavior at a later stage through BIOS updates. With Sandy Bridge, Intel also added an integrated clock generator and essentially cut off any external control over the base clock frequency. Overclocking control was now almost entirely under Intel's control. While this tight control wasn't really a problem for Intel as a whole, an internal group of enthusiasts and overclockers did realize that actions had to be taken if not only overclocking was to be maintained, but also enhanced in future platforms. In a 2013 interview, Mike Moen from Intel explained the origins and the purpose of this overclocking workgroup.
I have a couple jobs at Intel. One, I'm the lead engineer for high-end desktop and enthusiast platforms. The thing I focus on a lot is Extreme Edition processors, K-SKU processors. And so because of that, the other thing that I do is I focus a lot on overclocking. So I run an overclocking workgroup at Intel. I started back actually with Nehalem, so 2007, 2008 timeframe, and one of the VPs at the time said, hey, let's see how fast this thing can go, and that sounded kind of fun to me actually, so I just got in the lab with a couple of the performance architects and we started fiddling with things and got some great results, and it has kind of just continued to roll on from there. Well, one, I think the most significant thing we try to do is we try to be a community of users within Intel, right? We're all doing this because we love what we do. We love the architecture. We love making things go fast. And so we try to look at each platform that comes along and we try to figure out, you know, if this is the way that an overclocker is going to use it. We try to figure out, given the level of integration that is going on with each platform, how we can leverage that, how we can expose the right knobs to allow an overclocker or a performance tuner to be able to do neat things with the platform. Yeah, so, you know, while we don't, you know, per se absolutely engineer for the overclocking regime, we're engineering for a very broad range of applications and usages. But the thing that we want to make sure and do is that the logic that is designed in isn't going to be an impediment to the overclocking experience. So, you know, physics is going to be your limiter, not the logic. You know, I think that, you know, this is where I say that I work with a lot of really smart people, and these guys are designing some really innovative circuit solutions, and one thing that they don't always know is just how people are going to use them. And so one thing that we do is we actually connect sometimes this community of users and what they're doing with it. We connect them with the architects and the designers, and they're like, oh, that's really cool. And suddenly they can, because naturally, you know, being an engineer, being inquisitive, they're going to say, you know, why don't you show me what that does down there, right? And when we say, well, this is what it does, and it sure would be nice if it did something different, right? Sometimes we get them to jump in and say, okay, let's try to figure out how to fix it. So, and I think that's just kind of the natural thing of an engineer that loves to see just what their design really can do. They want to see the limits, just like, you know, the people that are doing overclocking out there, they want to see the limits. There's not that much of a difference sometimes.
While Mike has since left Intel, his successor Dan Raglan now heads the Intel Overclocking Lab. He and his team continue to push the overclocking agenda within the organization. For those who want to get to know Dan, both Intel and Tech Potato have excellent interviews on their respective YouTube channels. Where Nehalem would introduce features that would end up severely restricting overclocking on Intel platforms, Haswell perhaps introduced the most consequential feature for overclocking that enthusiasts have never heard about: the OC Mailbox. The OC Mailbox is a model-specific register, or MSR, interface which communicates directly with the CPU power control unit. It is designed to program overclocking and overvolting parameters to the CPU. Over the years, the OC Mailbox has replaced many legacy overclocking programming functions and significantly expanded its scope. From the business perspective, Intel uses the OC Mailbox in two main ways. 1. To increase value for enthusiast K, SKU, and Z chipset customers by enhancing and expanding overclocking and performance tuning functionality. 2. To gatekeep and restrict overclocking for non-K and non-Z products. Therefore, in theory, the OC Mailbox should be locked unless you have a K or an X CPU and a Z or an X motherboard. This has a significant impact on the overclocking experience of non-K processors, as it means no voltage offset or override, no turbo ratio control beyond the default maximum limit, no per core ratio limit, no VF points, no BCLK aware adaptive voltage, no thermal velocity boost functions or OCTVB, and no AVX offsets. I need to mention Skylake, as there are striking parallels with non-K overclocking on Alder Lake. Skylake introduced a new feature called BCLK Governor, an integrated circuit that calculates the base clock frequency at real time and will issue a machine check error if the BCLK is higher than the allowed limit. Importantly, BCLK calculation doesn't rely on using the integrated clock controller from the PCH, as it works with external clocks as well. External clocks? Yes, another key new feature on Skylake was the re-enabling of full-range, fine-grained BCLK overclocking. For this purpose, motherboard vendors could add an external clock generator to the motherboard, bypass the internal clock generator, and use it as the base clock frequency. The result was quite spectacular, as the BCLK could overclock to over 550 MHz, the highest since the Core 2 days. With this kind of BCLK overclocking range, Intel definitely needed its BCLK governor to both monitor the BCLK frequency in real time and make sure that the CPU stopped working once it exceeded a hard-coded limit. On December 2nd, 2015, almost 4 months after the launch of Intel's 6th generation processors and brand new CPU architecture Skylake, the overclocking world woke up to a Core i3 6320 processor with an overclocked BCLK frequency of 120 MHz. As we'd learn in the days and weeks to come, Supermicro had found a way to work around the power control unit, which is responsible for managing the CPU's power consumption, performance, as well as housing the BCLK governor. With the PCU out of the way, there was no means to check the BCLK frequency and throw an error, so non-K overclocking was back. Unfortunately, disabling the PCU came with a couple of significant drawbacks. Despite the drawbacks, some motherboard vendors went all in on promoting non-K overclocking. Most notably, ASRock had set up an entire marketing campaign for its Sky OC feature. As expected, Intel pressured motherboard partners to remove non-K overclocking support, and most motherboard partners withdrew official support. That said, extreme overclockers and enthusiasts could still find and use the old BIOSes with non-K OC support. The BCLK governor measures the real-time BCLK frequency and checks it against a hard-coded limitation. Since Skylake, the BCLK limitation is 103 MHz. So while the highest non-K BCLK frequency for Skylake was 213 MHz, ever since Skylake, the non-K maximum BCLK frequency is about 103 MHz. To the untrained eye, it may seem that there's nothing special about the unlocked parts, but once you know the tremendous value created through the efforts of expanding the OC Mailbox, you start to appreciate the work Intel's OC Lab team is doing to enable overclocking. Note that access to the OC Mailbox is entirely up to Intel. They can fully unlock it for certain processors, they can partially unlock it, or they can just fully lock it down as well. It's really up to them to decide. Also note that enabling non-K overclocking for Alder Lake processors does not grant you access to the OC Mailbox. All the OC Mailbox restrictions for non-K Alder Lake processors are still in place, even after unlocking the BCLK. So let's come to the point of this video. With all these restrictions in place, how on earth is it possible that we can do non-K overclocking on Alder Lake? Due to an apparent oversight, the BCLK governor does not function correctly on a specific older pre-release version of the CPU microcode 0x9. The BCLK governor works correctly for the integrated clock generator, but not for the external clock generator. Using this older microcode in combination with an external clock generator means you can increase the base clock frequency on a locked, non-overclockable part beyond the artificial limitation of 103 MHz. We can only speculate as to why that oversight happened. One theory is that it has something to do with the fundamental change in clocking structure on Alder Lake. Since integrating the clock generator on Sandy Bridge, it's always been the PCH that generates the 100 MHz BCLK frequency. That was the case until Rocket Lake. However, first on Tiger Lake and now also on Alder Lake, the BCLK is added on the CPU die. The 38.4 MHz crystal still connects to the PCH, but instead of driving a 100 MHz clock to the CPU, the PCH now just forwards that 38.4 MHz clock to the CPU BCLK PLL. The CPU, in turn, generates its 100 MHz reference clock. This fundamental change in clocking structure may explain why the oversight occurred. Obviously, Intel wouldn't want the non-K parts to be overclocked using unsupported methods. I don't quite believe it's only because of financial reasons. I think it's primarily because of safety reasons. Intel doesn't want a third party to be able to make your system unstable using this unsupported method. Anyway, considering that this exploit or this oversight is not present in later microcodes, I don't think Intel will come down too harshly on this non-K overclocking thing. Intel can encourage motherboard partners to ship new BIOSes without this older microcode, or could even enforce updating the CPU microcode via a Windows update as it did for the unlocked Pentium G3258 Anniversary Edition and non-Z motherboards. Motherboard vendors have a couple of ways to support non-K overclocking. First, they can provide specific BIOS releases with microcode 0x9 to end users. Second, they can release BIOSes with both microcodes and allow users to choose which microcode to load. That's how it works on the Aaccess ROG Maximus Z690 Extreme motherboard. By enabling the Unlock BCLK OC option, the BIOS will load the 0x9 microcode. If this feature is disabled, it will load the latest microcode. That's 0x15 on my 0801 BIOS. So in summary, on microcode 0x9, the BCLK governor doesn't work properly, as in it doesn't monitor the external clock generator. This gives us access to BCLK overclocking, essentially unmonitored BCLK overclocking. While we have access to the BCLK, it doesn't mean that we have access to any of the advanced tools available in the OC Mailbox. So while we can overclock, we still have a lot of restrictions that will prevent us from doing it very easily for a daily system.